Okay, Assalamualaikum warahmatullahi wabarakatuh. Alright, for today's lecture, we are going to move to another chapter, which is on the chapter 3 on structural steel design according to Eurocode 3. For today's lecture, we are going to touch on the introduction part of the steel design. Course outcome is on the CO1, CO2, and CO3, which is live with the programmed outcome PO2, PO3, and PO4. The learning outcomes at the end of this lecture, you are able to understand a steel as a structural material, and then you need to describe the differences between the ultimate limit state and also serviceability limit state according to Eurocode 3. Okay, what is steel? Steel as a construction material is actually an alloy consisting mostly of iron with carbon content between 0.2% to 2.14% based on weight, and the variation of the content is depending on the grade of the steel. Some of the steel have another elements that influence the grade of the steel. For example, let's say the magnesium, manganese, silicon, phosphorus, and aluminum. Those steel have been produced by various inefficient methods long before the Renaissance, but it used to become more common after the 17th century. For production of steel, it started from all the material will be combined in a furnace to become a molten steel, and the output of this process is ingots. From the ingots, we reheated of the steel to red hot, and then we rolling mill to become a section of the steel member. So we have beam section, hollow section, channel, angle, and also plate. The advantages of steel is due to the high strength of the steel as compared to the weight of the steel. And also the steel can be prefabricated, and it has advantages on the ductility of the steel and also the elasticity of the steel. And the steel is also tough as compared to the concrete, so we can add more load to the steel, and also the steel can be used as permanent, and also can be used as addition to the existing structure. The disadvantages of the steel is the first one is the corrosion of the steel, and also because steel is lost its strength in high temperature, so we need extra cost to put a fireproofing elements to our structure. And the disadvantages of steel is also due to the susceptibility to buckling as compared to the concrete structure. Steel is also disadvantages in terms of the fatigue and also brittle fracture. What are the type of steel structure that we have? So normally, steel structure can be used as building frames, which is loads must be supported safely and without undue movement for the frame. So weatherproof envelope must be attached to the steel structure. In building frames, the steel frame consists of skeletal framework which carries all the loads of the building. And the common type of the steel frame building are shown as below. The first one is a single-story lattice roof building with crane, and also we have single-story rigid pin base portal and multi-story building. In steel frame, what we have is a floor beam, then we have a plate girder, column, bracing, and haunches joint, or also crane girder. These are all the elements that we have in uh, frame buildings. The second type of steel structure is on containers, which is a component can contain other components inside itself, such as holding liquids or gases. The usage of the container is for refineries, high pressure tank, oil tank, and also water tank. Steel also can be used as mast, chimneys, and bridges. Bridges is actually a structure built to span physically obstacles such as a body of water, valley, roads, or river. The purpose is to provide a passage over the obstacle. Design of bridges vary depending on the function of the bridges and also the nature of the terrain where the bridges is constructed, and also subjected to the material used for the bridges. There are several types of bridges. So for example, we have suspension bridge, cantilever bridge, cable steel bridge, movable bridge, beam bridge, arch bridge, and also double deck bridge. Here are the example of bridges, different type of bridges and the shape of the bridges. And another type of structure using steel is temporary support. Uh, Temporary support is required to secure any elements or element of the steel framing only until they are made stable without external support. After that, we can remove the temporary support. For the example of temporary support is scaffolding and also shoring. Alright, so let's look into what are the elements of steel structure. The first one we have beam and plate girder. Beam is a member carrying a vertical action from above, and it reacts in bending and shear. A girder is actually a beam, a fabricated beam formed by the welding of plate together with I section. This is an example of plate girder, which is we have plate on the top of I beam. And then we have another type is ties. Ties is any strong component designed to keep two objects closely linked together. The members carrying axial action is in tension. So this is a tie. Basically, we use for trusses. And also we have strut, column, and tension. Strut is compression member. Normally we use as bracing. And the column is also compression member, mainly supporting a vertical compression member. And tension is main vertical compression member in portal frame. So let's say you have a portal frame. Portal frame, basically you have a column and beam connected together. And then we also have truss and lattice girder. Uh, Truss and lattice girder normally on a frame structure that the frame members will carrying axial load, which is composed due to struts and also due to ties. A combination of strut and ties and become a trusses and lattice girder. This is example of trusses, and here lattice girder used in a beam in bridges. We also use steel member as a purlins, which is a beam members that carrying roof sheeting. So normally this purlin, the strength of the purlin is low as compared to the beam, actual beam. Okay, we use only to support the roof sheeting. And we also have steel sheeting rail, which also beam members supporting a wall cladding. This is the sheeting rail supporting the cladding. Wall cladding is basically we use to protect our structure from weather. And steel is also used as bracing. Bracing is actually a diagonal strut and ties. This is what we call as bracing. Together with column and roof trusses to form vertical and horizontal trusses to resist wind or horizontal forces. The function of bracing is actually to stabilize the building. And this structure element must be joined together and the building must be attached to the foundation. The joint actually connects the members together. For example, we have joint in trusses, joint between floor beams and column, and also beam to column joint. And the joint will be transmitting the load, let's say from beam to column and then to the foundation. Okay, so let's move on the structural steel section. The main section is hot roll section, which is we produce a section by hot rolling of steel billets or block of steel, and then we put it in a mold and in a rolling mill. So the most common type of hot roll section is universal beam. The shape of the universal beam is I shape, and sometimes we call it as I beam. And also we have universal column. The shape of the column is actually H section. We also have hot roll section, channel section, C section, and also rectangular and circular hollow section or equal angle. And another type of steel is cold form section. For cold form, the steel plate is produced and then by shipping of unheated steel sheet by cold bending or cold drawing or cold drilling at room temperature to become a form section. For example, let's say we have a steel plate and then we shape it into Z. And we call it Z section, and also we have sigma section and also lip channel. And we also have what we call as build-up section. For build-up section, we weld the plate together to form the shape of I, H, or box member. Okay, so sometimes we have plate girder, build-up section, box girder, or box column. And also we have steel section that we call as metal sheet. Normally used for composite construction as a permanent formwork for slab. Alright, next is on the steel design theory. So in steel design, we have we have three theories, which is elastic design, and then we have plastic design, and also limit state design. For steel design, we are based on this stress strain curve. So normally at a point, a steel will act as elastic until the point of yielding. YU is upper yield limit, and when we still apply the loads, then the steel is start to loss its strength a little bit, so we call it as lower yield limit. And then the steel strength is still goes up until at certain point we call as ultimate stress. And after that, when you still apply the load, the strength is reducing and until it become fractured. And at this point, from the ultimate limit stress to the fracture point, what we call as necking, and from the yield point to the ultimate stress is what we call as plastic deformation. In elastic design, the maximum action that a structure could support is assumed to equally the action that first caused by stress in the structure. Steel is almost perfectly elastic up to the yield point, and that the structure are analyzed by elastic theory. We assume that the section size will not exceed the yield stress. The main problem in elastic design is the steel itself is a ductile member, which is normally does not fail due to great yielding. Or when it reaches the yield point, normally the steel is still not fail. So it means that the margin of the safety for the steel structure is still high. So it makes the design uneconomical because the full potential of steel is not utilized. And next we have what we call as plastic design, which is we consider the plastic state of the steel. The advantages of this is we can take the unique property of steel, which is ductility, and we take in design the behavior of the steel after the yield point until it's collapsed or fractured. The plastic design will also take in consideration of the long yield, which allow the possibility of plastic strain at the constant stress. However, in reality, the structure can fail not only due to failure of the material, but also due to excessive deformation. It means that when we apply load, the steel may be still strong, but the structure is actually failed due to deflection of the structure. Therefore, another design theory that we introduce is limit state design. In limit state design, we have limit state design in terms of serviceability limit state, and also we have ultimate limit state. So basically, this limit state is quite similar to the one that you have done in concrete design, which is in serviceability limit state, we are designed for the deflection of the structure or vibration induced by the wind or damage due to fatigue, and also in terms of corrosion and durability. In serviceability limit state, when the limit is reached, the whole structure or a part of it is unfit for normal use. However, at serviceability limit state, the structure does not collapse. It just cannot be used. Does not collapse, but cannot be used. And for ultimate limit state, we design for the strength of the structure. For example, for yielding, rupture, buckling, and also the transposition into mechanism. At ultimate limit state, you are designed also against overturning and sway of the structure or fracture due to fatigue or brittle fracture, and also ductility check. At ultimate limit state, when the limit is reached, the whole structure or part of it may collapse. Okay, so that is the difference between the serviceability limit state and also ultimate limit state. So in Eurocode, so basically in Eurocode, we have the first one, we have EC0, which is on the basis of design. This is applicable for all the Eurocode series. And then we have EC1 is based on the action or loading on structure. And then we have each code for each material. So we use EC2 for concrete and EC3 for steel. And also there are other series of Eurocode for different purposes. So action on structure for steel design is actually similar to the one that you have done in concrete design, which is you are going to have a permanent action and also variable action. So permanent action is actually a constant loading during the life of the structure, that what we call as dead load. It is include the fabric of the structure or any architectural components such as cladding, partition or ceiling that is fixed to the structure. It can be also any equipment or static machinery, And for variable action, it's actually load that varies with time, or what we call as impulse load or live load. For example, let's say occupants, furniture, snow, retained water, thermal expansion, shrinkage, and so on. And the load factors for designing of steel is quite similar to design of concrete. So the expression that we use is 1.35 GK plus 1.5 QK. So that is what we use for general design. Unless we are going to extend our design for wind loads or snow load, then we need to add any other variables factors. Okay, so here is the design appendix that we are going to use, which is design appendix for structural steel design. So for this appendix, we are combine all the EC3 elements that we are going to use during the design. This is not a complete of EC3, just a part of EC3 that we are going to use. And also we are going to refer to this book, The Design of Structure Elements by Chanakya Arya. Okay, the copy of this material will be provided in the future. Alright, so that's all for the introduction of the steel design. So next class we are going to continue on the designing of beam, steel beam. Alright, thank you very much. See you next time.